Alright, so we're going to talk about these last two examples from our guided notes. So first one, we have 2 balls are to be selected without replacement from a bag that has a red, a blue, a green, and an orange ball. So first thing we want to do is use the counting principle to calculate the number of points in my final sample space. So we have 4 possible outcomes on that first time that I pick a ball out of the bag. It could be red, blue, green, or orange. So that's going to be my first one is 4. And then we want to multiply it by the number of possible outcomes of the second time. But since whatever I pick from the first one won't be put back into the bag, I only have 3 possible outcomes of that second time I pick a ball. So that means that I'm going to have 12 outcomes here. 4 times 3. So now I want to construct a tree diagram and list the sample space. So again, you just want to start by making branches of all the possible outcomes and then just keep building off of the branches from that first or second event until you get to the end. So if I were to start this tree diagram, I have these 4 possible outcomes. So I have, let's see, we got red, blue, green, and then orange. Now we want to keep building this tree diagram, but the key thing here is without replacement. So that means that one of the other 3 would have to be picked. So that means if I drew a red, second time that I drew a ball, it would have to be blue, green, or orange. If I drew a blue, it would have to be red or green or orange. If I drew a green on that first pick, it would have to be blue or red or orange. And then if I drew an orange, it would have to be red, blue, or green. So that's it. So there's my tree diagram. And then to list my sample space, again, what you want to do is kind of just follow the branches of the tree. So I could have a red and then a blue, or a red and then a green, a red and then an orange, a blue then a red, a blue then a green, a blue then an orange, green then blue, green then red, green then orange, and then orange then red, orange then blue, and then orange then green. So there's my sample space in my tree diagram for that. So now we want to know what's the probability that one orange ball is selected. So we want to then look at our sample space. Again, how many of these outcomes have one orange ball in it? So we have red then orange, blue then orange, and then green, orange, orange, red, orange, blue, orange, green. So there are 6 successful outcomes over my possible 12. So that means that I have a 1 in 2 shot out of picking an orange ball at least once. And then we want to know what's the probability that a green ball followed by a red ball is selected. So this isn't just green and then red, so this is green then red. It's not just a green ball and a red ball. It's green followed by red, which makes the order very specific. It has to be green then red, so there's only 1 out of 12 that follows that. And then for the next one, we have at a restaurant, each lunch special consists of a sandwich, salad, and a beverage. The sandwich choices are roast beef, ham, or turkey. Salad choices are macaroni or potato. And then the beverage choices are coffee or soda. So, counting principle to, again, find the number of different lunch specials. So we're going to pick a sandwich. We have 3 different options there. Salad choice, we have 2 options there. And then a beverage choice, we have 2 options there. So 3 times 2 times 2. That gets me 12 different possible lunch specials. So then we want to construct a tree diagram and then list our sample space. So we want to start off with our first piece of this experiment or event, which is getting a sandwich. So that means we could have roast beef, or we could have ham, or we could have turkey. Then we want to go to our salads, so macaroni or potatoes. So we have to build off of both branches there, or all 3 branches. So they're going to have 2 branches. And then last one, coffee or soda. So we have to build off of each branch of the salad. Coffee, soda, and then coffee, soda. Okay, so there's my tree diagram here. And then my sample space, just following my branches. I have roast beef, macaroni, and coffee, roast beef, macaroni, and soda, roast beef, potato, and coffee, roast beef, potato and soda, ham, macaroni, and coffee, ham, macaroni, and soda, ham, potato, and and coffee, and then ham, potato, soda, turkey, macaroni, and then coffee, turkey, macaroni, soda, turkey, potato, coffee, turkey, potato, soda. So there's my sample space if I just follow all of the branches there. So now we want to know if a customer randomly selects a lunch special, determine the probability that roast beef and soda are selected. So again, we have 12 possible outcomes, so it's going to be something over 12. So we have roast beef and soda. So we want both of them. So we have roast beef, macaroni salad and soda, or roast beef and potato salad and soda. So we have 2 possible successful outcomes, which means that we have a 1 out of 6 probability of having a lunch special that has both roast beef and soda in it.